Alright, so I want to go over how to complete a dihybrid cross with you guys. We're going to start off by looking at the crosses on this sheet that's already complete and how that is actually done. So on this cross, you are crossing a homozygous dominant parent with a homozygous recessive parent. So that is a tall green pea plant. It's crossing two traits. So go over to the side if you need to, always, and give yourself a key. Big T means tall, which means little t is going to be short, right here. And then green is going to be dominant, again, big G. So little g will be white. So what you do, the easiest way to complete a dihybrid cross is, because you are combining two traits, which is why it's called di, you are going to use what's called the FOIL method. FOIL is the same technique that you use in math. You're just using it in order to complete and fill out the parents, which are on the top and are on the side. So with that, we have the first parent, which is big T, big T, big G, big G. So with FOIL, FOIL means first times first. The O is outer times outer. The I, inner, times inner. The L will be last times last. So this means you're looking at each of these like they are variables. So you do first, big T, times first. So that's big T, big G. First times first. Then the O is outer times outer. So that's outer times outer. Inner times inner. Last times last. And these are all of the genotypes that will go on the top for the parent, which is what's shown right here. So that's what these are. Okay, so let's do that with the other parent. Little t, little t, little g, little g. So first times first, outer times outer, inner times inner, last times last. And that's what you have right here. The second parent. Now, whenever you're completing and actually filling in the squares, you keep the letters together. So if you look, you have a capital T and a lowercase t. So those two are together. Then you have a big G and a little g. So those two the letters are together. Now, when you're looking at it, you are going according to genotypes and phenotypes. So what you'll do is you take the first box and you see how many of those you have. So every single one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16 out of 16 will be big T, big little t, big G, little g. So 16 out of 16 are heterozygous. Okay, so now let's do this one together. So you are crossing a tall green pea plant So that's big T, big G, little g, with a tall green pea plant. So that is big T, little t, because this one now is heterozygous. So again, keeping to your foil, you'll do first times first, outer times outer, inner times inner, and then last times last to get your parents. So that means up here on the top, big T, big G, big T, little g, big T, big G, big T, little g. Okay, so that's parent 1. Parent 2, first times first, outer times outer, inner times inner, and it's okay to have the little letter first right now, just because we're keeping the T's first, because that's what they gave us, T first. The trait for tall came first. And then last times last. That parent's going to go on the side, so that is big T, big G, big T, little g, little t, little g, oops, sorry, little t, big G, and then little t, little g. Okay, now whenever you're filling these in, remember, you keep the letters together, so big T, big G, big G. Then you go over to this one. Still the same thing. This one comes down, this one comes over. So that is big T, big G, little g, big T, big G, big T, big G, big G, little g. Go down to the bottom, or to the next one. Big T, big G, little g, big T, little g, big T, big G, little g, big T, little g. Next one. Now on this one we have differences in the T's, like we did with the G's on the first one. You put the capital letter first for that particular letter. So you have a big T here and a little t here. We'll put the big T first, little t, big G. Same thing. Same thing with the G's. Big T, little t, big G. So this one, big T, little t, big G, little g. And then your very last row, big T, little t, big G, little g, big T, little g, big T, little t, big G, little g, big T, little g. Now, for your traits, because this is a lot of letters, and I understand that, for your traits, always come over to the side and make yourself a key. So we have big T. Big T stands for tall, which means little t is short. Big G stands for green because that's the dominant trait, which means if we're using the same ones, little g will be white, just like it was up here. Now, when you're doing this, you're trying to see how many of each trait you can actually have. So the best way to go about this is to go with your first trait. Big T, big T, big G, big G. This is going to be, you have, if you look through, you only have one of those, right? There's no other that are big T, big T. Oh, wait, yes we do. We have one more here. So we have two of those. Let's see if we have another one. So you go through, check every single one, just to be certain. Okay, so we only have two of those. This will be tall and green. So we are now looking for all that could be considered tall and green, which means they have at least one big T, one big G. So that's 2, tall, green, 3, tall, green, 4, tall, green, 5, tall, green, 6, tall, green, 7, tall, green, 8, tall, green, 9, tall, green, 10, tall, green, 11, tall, green, 12. 12 tall and green. So now let's look for tall and white. A tall and white will be a big T and then a little G somewhere, right? So now let's look for ones that will be big T, little G. Big T, little G, that's 1. And you can do this in a different color if you need to. 1. Big T, little G, 2. Big T, little G, 3. Big T, little G, 4. Which means short and green will be a little t, big G, and doesn't really matter what that other letter is because green is dominant. You have none that are little t, and then short and white will be completely recessive, and there were none in here that were completely recessive. All right. Let's do one more, and then you guys are going to do the rest. So now you are crossing a tall green pea plant with a short yellow pea plant. So now you see our traits have changed. So big T is tall, which means little t has to be short. See? And then big G is green, which means little g will be yellow. So again, big T, big G, little g, which is your first parent. Second parent will be little t, little g, little g. All right, so filling in your parents, remember FOIL. First times first, so that's big T, big G. Outer times outer. Inner times inner. Last times last. Okay. Over here, first times first. Outer times outer. Inner times inner. Last times last. And now you go to fill them in. So you bring your T's down, bring your G's, then do the G's, bring the T's, then your G's. Now remember, we're doing the T's first because they gave us the T's first. If they would have actually put the G first, then you would be using the G first. It just depends upon which way they give it to you. Whichever trait is given first, that's the one that goes first. So you fill these in. to see what all you have. If it gets confusing, go through and do all the T's first and then fill in the G's. So like for example, we can do big T, little t, little t, little t, little t, little t, and then go down to the bottom. Big T, little t, big T, little t, little t, little t, little t, little t. Now let's go back and do our G's. Little g, little g. Big G, little g. Little g, little g. Big G, little g. Little g, little g. Big G, little g. Little g, little g. All right, so now let's look and see what we have for tall and green. So tall is your dominant trait. Now remember, it only takes one of the traits or one of the capital letters to show dominance. So that means we're looking for something with a big T. It doesn't matter what that second letter is. Green is a dominant, so something with a big G with it, it doesn't matter what that second letter is. So anything that's like this, that means it could be big T, big T, big G, big G, big T, little t, big G, little g. Any of those, instead of having to write all this out, you can just put a dash instead, which is what those little dashes are. That's what I did up here. So let's try that with tall. So tall is a dominant trait, so that's big T. Since it's dominant, it doesn't matter what that second letter is. Oh, it's using white. So let's change this. That's fine. White is recessive. So if white's recessive, that means that is little g, little g. So your options for that one, big T, little g, little g. Big T, little g, little g. The reason this one can't change is because this one is fully recessive. Which means if it's fully recessive, it's going to take two small letters to be shown. Otherwise, it will be dominant if it has that capital letter. So these are the options for the first one. These are your options for your second one. Let's look at this one, short. Short is a recessive trait, which means it takes two short alleles or two short letters to show it. Green is dominant, so we can do G and dash. So the options for that one are little t, big G, little t, big G, little g. Now this one is fully recessive. So that is little t, little g, little g. There are no other options for this one because it is fully recessive. So now let's look for any that we have that are going to be tall and green. Now remember, we're looking for these here, big T and a big G. So for tall and green, I'll go through and highlight them as we do them, as we find them. So big T, big G, this is one. That one won't count. That one doesn't have a big T. That one doesn't have either. This one will count. 2. Doesn't count. Doesn't count because there's no big T. This one doesn't have any big letters. 3. This one doesn't have a big G. This one doesn't have a big T. This one doesn't have either. And then this one. No big G, no big T, neither. So this is 4 that we have that would be tall and green. So now let's look at tall and white. So if it's big T, little t, and all little g's. So now let's find that one. Capital T and both little g's. So capital T, both little g's. Not a capital T, not both little g's. Not a capital T, little g. No capital T, no capital T. Capital T here, and little g. No capital T, no capital T. All right, and then this last one right here. Capital T, little g, no capital T, and then not a capital T either. So that means we have 4 of these. All right, now let's look for short and green. Short and green will be little t, and a big G, which if you start to look and you can tell, that's going to be these 4 right here. So that's 1, 2, 3, 4. And then short and white are both fully recessive, so that will be 1, 2, 3, 4. And notice as I go through, I'm doing something to mark them out. That way I know that I've already counted them and I don't accidentally count them twice. So you don't get it too mixed up. All right, so now that you've done that, you guys try the back and try this page. On this page, I will help you with the first one like I did on the others. Just because it does look a little wordy for you guys, even though it's not that bad. Now, if you think you have it, stop and go for it. You don't need me. If not, walk through the first one with me on this page, and then you should be able to understand it. So set up a Punnett square using the following information. Dominant allele for tall is big D, recessive for dwarf is little d. Dominant allele for purple flowers is big W. Recessive allele for purple flowers is little w. Cross a homozygous dominant parent with a homozygous recessive parent. Okay, so remember FOIL. If you need to write it out, write it at the top. That way you don't forget to do it. First times first. Outer times outer. Inner times inner. Last times last. All right, and on the bottom one, this is your parent 2. First times first. Outer times outer. Inner times inner. Last times last. And then remember, if you need to, now this is something that I used to do just to get myself adjusted to them, I would go through and do all the first letters in the boxes. So I would go through and do all of my D's. Just because it was easier and I didn't get them all mixed up. So big D. And I know all of these are big D's, so I'm going to fill this one down. Down. And then I'm going to do the little d, fill it over. Little d, fill it over. Little d, fill it over. And over. Now you go back and do all of your W's. So let's do the big W's first. Fill those down. And now if you notice, I'm making sure my big W is really noticeably large, just because a large W and a little w sometimes are hard to tell the difference in. So big W, big W, big W, big W. And fill all of these in. Now let me go through and fill all my little bitty W's. Now, what I always say is if it's a letter that's hard to tell whether it's dominant or recessive, put a little line up above them if you need to. The D's are usually easy to tell, so you can do a W like this for recessive. Or what I like to do is I over-exaggerate my capital and then under-exaggerate my lowercase so I can distinctly tell the differences. I'll do both. Like this. So we're going to fill the W's over. And you see how I'm making that lowercase really, really tiny? And I'm putting that line up above it just to make sure I don't mistake this for a W that could be possibly capital in any form or fashion. So you have your questions over here. What is the probability? Now when they ask for probability, this could be a percent or a fraction. Either one. So what is the probability of producing tall plants with purple flowers? So tall plants means it has a capital, I was about to say T, a capital D. And remember, it only takes one letter to show dominance, so it doesn't really matter what that second letter is. And then purple flowers, according to this, purple flowers is a big W. So we're looking for big W, and if it's dominant, it doesn't matter what that letter is. So before you do probability, sometimes it's easier to list what all the genotypes could be. So we could have big D, big D, big W, big W, big D, big W, little w. But if you look over here, the only option you have, since you have no big D, big W, big W's, then that means you are going to not have this as an option. And so they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of 16, which is 100% tall purple. All right, so what is the probability of producing dwarf plants? Now, if they're dwarf, go over here again. Dwarf is little d. Remember, the only way to show recessive, which is the little d, is for both letters to be recessive. And white flowers, again, fully recessive, so that means 2 little w's. The only possible genotype for this is little d, little w, little w. So then you go over here and first look for the little d's. See if any of them have 2 little d's. If they don't, then that pretty much answers that question, because you have to have the 2 little d's. It doesn't matter if it has the 2 little w's if you don't have this first part, since we're looking at these two traits together. So that's 0 out of 16, 0%. C, what is the probability of producing tall plants with white flowers? So again, tall means big D, doesn't matter what that letter is. White flowers is recessive, so that's little w, little w. Possible genotypes are always easier to do. You could have fully dominant for tall, or you could have heterozygous and then white. So we need to see which combination, because the only real difference between these two is those 2 little w's. So that's going to be the easiest one to search for. So look through each one of these, and you're looking for 2 little w's together. And there is none. So that means 0 out of 16, which is 0%. What is the probability of producing dwarf plants? So a dwarf plant is little d, with purple flowers. Purple flowers are going to be dominant, so that's big W, and it can be anything after that. So the possible genotypes for that are little d, big W, little d, big W, little w. So now, if you look, the big distinguishing difference are these little d's here, because that's kind of the same. So let's look for anything that has a little d. And now whenever we're looking, we should be looking for 2 little d's together like we have right here. And that's 0 out of 16, which is 0%. All right, and that should be it.